What's the common mistake students do in taking the squares of binomials? So sometimes when students answer questions like finding the square of binomials, what they do is to square the first term and the second term. Okay, that is the one common thing that students do. Like if you have x plus y, quantity raised to the second power, when they see this, what they do is to simply raise the first term, which is the x here, to the second power, and then they do the same thing with the y. So the first term and the second term being raised to the second power. So this is a big mistake. Okay, again, this is wrong simply because when you are taking the square of binomial, this simply means that we are supposed to multiply the x plus y, which is the number here in the quantity, by itself. So the meaning of x plus y raised to the second power is actually x plus y multiplied by itself. And so therefore, in this case, we cannot just square the first term and the second term. What we need to do now is to apply the distributive property, wherein you have to multiply all the terms by each of the terms in the other quantity. So if we are going to do that, that is in mathematics, we are making use of the FOIL method. So if we remember, the FOIL stands for the first terms, and then we have the O for the outside terms, the I for the inner terms, and the L for the last terms. Okay? Or sometimes we can just say that if you are looking for the square of binomials, we have to square the first term, then twice the product of the first and the second term, and then we have to square the last term. Again, if you are going to do that, we have to square the last term, square the first term, I should say. So we have x raised to the second power, twice the product of the first and the second. So we have to multiply the first and the second term, x and y, that is xy, but you have to multiply that by 2. So that will result to positive 2xy. And then you have to square the last term, which is y. So that means y raised to the second power is the third term. So there should be a trinomial, which is a product of the square of your binomial. So again, this is a big mistake. The x squared plus the y squared is a big mistake. Now, if you are going to use the FOIL method, which is the long process, we have the first term. So we have to get the x. Okay, we have to get here x multiplied by x, and that results to x squared. And then we have the outside terms. The outside terms is x and y. Okay, so if you are going to do that, that becomes positive xy. Okay, and then we have the inner terms. We have here the I, which is now the inner term. So y and x, and that will give you again your xy. And the last one is for the L, which stands for the last term. So y here is being the last term, and also the y. So multiplying y and y, the answer that you will be getting there is y raised to the second power. So again, we are going to get the answer, which is x squared. So x squared, we have the sum of xy and xy here. That is now equal to 2xy. And of course, your y squared. So this is the correct product, or the correct expansion of the x plus y raised to the second power. Again, the x squared plus y squared is a big no-no. And if you are going to answer 2x minus 3y quantity squared, so how do we do this? First, you have to square the first term. So that means 2x multiplied by 2x. That results to 4x raised to the second power. And then twice the product of the first and the second. Twice the product of the first and the second term. So we have to multiply 2x with a negative 3y. That results to negative 6xy. Multiply that by 2. So negative 12. The answer that we will be getting there is negative 12xy. That's sometimes the term that is mostly forgotten. And then the last one is the square of the last term or the second term. We have the negative 3y multiplied by negative 3y. That results to positive 9y squared. So that is the proper way of finding for the square of binomials. Again, square the first term, then twice the product of the first and the second, and then square the last term.